Optimizing Smart Contract Code. Module 4, Video 5. In this video, we will explore EVM and discuss techniques for optimizing the gas consumption of the smart contract code. We will learn how to write more efficient, cost-effective contracts that can thrive on the Ethereum blockchain by understanding EVM's inner working and leveraging best practices. But why is optimizing your smart contract code so important? Well, it is crucial for reducing gas consumption, making dApps more cost effective, and enhancing the user experience. Optimized code not only saves users money on transaction fees, but also reduces the strain on Ethereum network, allowing for better performance and responsiveness, improving the overall scalability of your dApp. You can optimize your code by avoiding unnecessary computations. If you can simplify the calculations and avoid using same operations again and again, you can significantly reduce the gas usage. We can do this by identifying and eliminating any repetitive calculations that can be pre-computed and cached, rather than recomputing them during each function call. Simplifying complex mathematical operations by breaking them down into smaller and more efficient steps. And finally, by doing computation-intensive tasks off-chain. These things will ensure that your customers enjoy a smoother and more cost-effective experience. Here is an example of simplifying calculation. Instead of iterating a b times and summing it, we just multiply a and b, simplifying the calculation, resulting in more efficient and cost-effective smart contract code. The same also applies for more complex computations, using efficient data structures. It's crucial to select data structures that optimize gas usage and improve the efficiency of your operations in the smart contract. For example, using mappings which act as key value stores, you can avoid the cost of iterating through an entire array. Additionally, you can further organize your contract's data by leveraging structs and enums. By using struct, you can group related data elements together. On the other hand, enums allow you to represent a finite set of predefined options, reducing the storage and computation required compared to using strings or numeric value. Here is an example of using these data structures in code. Using enum book status allows us to set status of the book to either available or borrowed. We use this in struct book to set respective data for every book. Then we can use books mapping, which maps book IDs to their respective book struct. This approach is more efficient in storing data. Optimizing function modifiers. Function modifiers are used to add additional logic or checks before or after a function is executed. If not optimized correctly, they can lead to increased gas consumption. One way to optimize them is to avoid repetitive checks within your function modifiers. Instead, you should try to use them a single time. Here is an example of using the ownership check into a single modifier. Minimizing storage operations. Storage operations are the most expensive gas-consuming activities in Ethereum smart contracts. It is absolutely crucial to minimize the number of storage reads and writes you use in your smart contract. You should use memory for temporary variables and only commit data to storage when absolutely necessary. This approach can significantly reduce the overall gas costs of your smart contract. For example, we can keep the results of intermediate calculations in memory and only write the final output to storage. This approach also ensures scalability of your dApps. Here is an example code of minimizing storage writes. In this code, data is only stored if it is different from the previously stored data. This conditional check ensures that the storage is only returned to when necessary, reducing the overall gas required to execute the function. Batch processing. Performing multiple operations in a single transaction can be a highly effective optimization technique. By batching multiple function calls or state updates into a single transaction, we can significantly reduce the overall gas costs associated with those operations. For example, in this code, the batch update function takes in an array of Ethereum addresses and a corresponding array of new balance amounts. Then, it updates the balances mapping for each account in a single loop. This technique helps to amortize the base transaction fee across all updates, providing a more cost-effective and efficient user experience. The key benefit of batch processing remains its help eliminating the overhead of repeated transaction fee. Using inline assembly. Developers can consider utilizing inline assembly to write low-level code directly in the EVM instruction set for advanced optimization. This gives greater control and helps achieve more efficient operations compared to high-level Solidity code. However, it is important to note that working with inline assembly requires a deep understanding of the EVM and its underlying architecture. Improper use of inline assembly can lead to unintended consequences and potentially introduce security vulnerabilities. So, it should only be used by experienced Ethereum programmers. In this example code, inline assembly is used to perform a simple addition operation. Leverage off-chain computation. To optimize the efficiency of your Ethereum smart contracts, consider offloading complex computations to off-chain processes. By this, you can reduce the gas usage required for on-chain operations, resulting in a more cost-effective and scalable dApp. This technique is particularly useful for scenarios where your contract needs to perform complex mathematical calculations, data analysis, or other resource-intensive tasks. By moving these computations off-chain, you can provide a more seamless user experience. Here is an example code where the store result function takes the computed result as a parameter and stores it in the result state variable. Optimizing event emissions. Events should be used to capture critical state changes and important transaction data. By logging only the necessary information, you can minimize the gas costs associated with event emissions and ensure your dApp remains cost effective for users. For this, you should consider the following best practices. Prioritize relevant events, limit event parameters, consider batching events, and leverage off-chain logging. Here is an example code of efficient event logging. Here, targeted event logging ensures that only the necessary information is recorded on-chain, making the contract more gas efficient and cost-effective for users. Using libraries wisely. By utilizing pre-built and tested libraries, you can reduce duplication, improve code maintainability, and optimize gas usage. However, it is crucial to use libraries wisely to ensure they provide genuine benefits without introducing additional complexity or security risks. You should carefully evaluate their functionality, performance, and reliability. Only choose libraries that align with your contract's specific requirements and are well documented, widely adopted, and actively maintained by the community. Avoid relying on untested libraries as they may introduce unexpected behaviors or vulnerabilities that could compromise your contract's integrity. Here is an example code which uses math library, which provides a simple add function that performs an addition operation on two integer values. To conclude, optimizing smart contract code is essential for reducing gas costs and improving performance. By avoiding unnecessary computations, using efficient data structures, and minimizing storage operations, developers can create more efficient and cost-effective smart contracts. Additionally, leveraging off-chain computation and using libraries wisely can further enhance the performance and maintainability of dApps. Next, we will be exploring tools and techniques for thoroughly testing and debugging smart contracts. Before we wrap up, here are some questions to consider. What are some additional strategies you can think of to optimize smart contract code? How can you apply these strategies to your current projects? For any queries and doubts, please be active on our Discord server. We look forward to hearing your insights and experiences in the upcoming discussion. Thank you.